second topic covered in this section is the Poisson distribution. The Poisson distribution is utilized when you have an average number of events occurring in some given interval. That interval can be an interval of time, an interval of distance. It could be just about anything. We could be talking about the average number of billboards per mile on an interstate highway. We could be talking about the average number of hurricanes that occur per year. Just about anything. But you're always going to have the word average or mean in the question, and you're going to have some interval given to you. So you want to look for the average number of blank per something. And that's going to be an indication that it's the Poisson distribution you're going to use. So this is number 20 on page 203. It reads, a newspaper finds that the mean number of typographical errors per page in the newspaper is 4. So again, we've got this mean number of errors is 4, and our interval is per page. Find the probability that on some randomly selected page, there will be exactly 3 errors found. There will be or at most 3 errors found. Remember, at most 3 errors would mean no errors, 0, 1, 2, or 3 errors would all be acceptable answers. So we're going to have to find multiple things and add them up. And finally, more than 3 errors, which means anything above 3, 4, 5, 6, 7, 8, 9 to infinity would be acceptable solutions. Again, with the Poisson distribution, like the geometric, there's not a finite number of trials. Only the binomial probability has a fixed number of trials. Really, the equation for this, the probability of x is equal to mean to the x power times exponential base e to the negative mean, all divided by x factorial. That's great. We're not going to use it. The much easier way to do this with Google Sheets would be to use a function called the Poisson distribution. And the Poisson distribution requires 3 entries. First, the x value, the number of errors in this case that we're looking for, the mean number of errors in the problem, in this case 4, and the word false. And similar to the binomial distribution we did last week, if we use false, it's going to give us an individual probability for each x value. If we use the word true, it will do a summation or a cumulative probability, which can be useful, but since we're going to make a distribution here, we don't need to do that. So we're going to come on in here. We're going to type equals, P-O-I-S-S, and you'll see it pop up right here, Poisson distribution function. And now it wants our input. So our first input is going to be our x value. Our x values are right here in this column. So we're going to highlight that and click, comma. Now it wants the mean, which is 4, comma. Now we're going to type the word false. Close our parenthesis and hit enter. And it has given us the probability that there will be 0 errors on a page is about 2%, very low. Which makes sense. If we expect, if on average there's 4 of them, the idea that a page is going to go by with none will be a pretty small answer. Now we can retype that, or we can just drag and drop. The probability that there's 1 error would be about 7%. Probability that there's 2 errors now is all the way up to about 15%. 3 errors, 4 errors, 5 errors, 6 errors. And again, this will keep going, and it started off small and they got bigger. Notice our biggest numbers are around 3 and 4 here, and that makes sense to us because you would expect there to be 3 to 4 errors per page. So we can go ahead and answer these questions now pretty simply. Exactly 3 errors can be found on a page. Well, that's this answer right here for 3, which is 0.195. 0.195. That is the correct answer according to the textbook. So we'll just come up here and we'll type in 0.1195. 5 is our answer. We'll round it off to 3 decimal places. And we'll highlight that in green so we know we got the correct answer there. Next one says, at most 3 errors on the page. Well, at most 3 means no more than 3, but 3 and anything below it would be acceptable. So we need to add up 0, 1, 2, and 3. We're just going to come up here and type equals the sum. And we'll go highlight our cells, 0, 1, 2, and 3. Close our parentheses, enter. We get 0.433, which again is the correct answer according to the textbook. And we're just going to come over here and we're going to tell it that we did the sum, parenthesis, and we started at cell B10. And we did the sum up to cell B13. So we know what we did there to find that answer. We can go ahead and highlight this row up here into format, number, and somewhere in here we should be able to round that off to 3 decimal places. Where's it at? That's 2 decimal places. There we go. Now it's going to round them off to 3 decimal places. We can go ahead and actually do that here as well. And we'll leave them at 3 decimal places. Format, number, and down here's 3 decimal places. There we go. Makes it a little cleaner, look a little nicer. Final answer here, more than 3 errors. That means anything above 3 from 4 to infinity is all an acceptable answer. So what is not acceptable to us? Well, what's not acceptable to us is 0, 1, 2, and 3. We want the probability that there's any value more than 3. So we're just going to come in here and we're going to do equals 1 minus the sum of 0, 1, 2, and 3 because those are the ones that are unacceptable outcomes to us. Go ahead and hit enter. We get 0.567, which is the correct answer. So that would be the sum of everything from 4 to infinity, whereas this is the sum of 0, 1, 2, and 3. We'll come over here, we'll type in here that we did 1 minus the sum of B10 to B13, so that we know how we did that. You could have also done these, at least this one here, using Poisson distribution and typing true. So if you would have input Poisson distribution, x value of 3, mean of 4, and type the word true, we'll go ahead and give it a shot. I don't want to delete my equation there, but we'll just go ahead down here and do it and tell it equals Poisson distribution, and we'll tell it x is 3, mean is 4, and we'll tell it true, telling it to do a sum of 0, 1, 2, and 3. We should get 0.433 again, and look at that, we did. So you can use the Poisson distribution with the true function to do the sums, and then you would just do 1 minus this answer again to answer letter C. So both options are there for you. I hope this clears up any questions you might have. If not, email me or use the question and answer doc. The first couple weeks, a lot of people use that. Recently, people haven't been using that. So if you have questions, get a hold of me. I'll do my best to answer. Let's go ahead and highlight our solutions here in green because we did them right. All right, thanks a lot.